If I underline something, write something, you write it. What does that symbol mean?
Conditional statement.
Conditional statement. So if I win the lottery, then I will buy all of you a new car. What you have to realize is that all of mathematics is man-made.
Why is it right around the border?
So maybe one of your projects for the second quarter, one of you, might be to figure out who developed this notation, who decided an arrow was going to be for an if-then statement or a conditional statement, who decided that P's and Q's were going to be our standard letters that we dealt with. But it's all man-made, so we have to apply it to real situations. If I win the lottery, then I will buy each of you a new car. Well, let's figure out if I'm telling the truth or not. Each of these rows here is a different scenario. What part of the if-then statement is the P? What do we call that? Hypothesis, and this is conclusion. What we're going to do is take a look at a situation where the hypothesis and the conclusion occur. Then we're going to take a look at when the hypothesis occurs but the conclusion does not. Then we're going to take a look at what happens when the hypothesis doesn't happen but then the conclusion does happen. And then we'll take a look at what happens when neither occurs. So we've got 4 standard scenarios. Whenever we do a truth table, put them in that order. True, 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 false, false, true, false, false. That way, when I'm correcting and looking over on the last column, I can see whether people are getting this correct or not. And that's the standard sequence for most textbooks. What does this mean? Well, for the first line, I won the lottery, then I bought everybody a new car. Did I tell the truth?
Yes.
So we're going to give the entire conditional a truth value of t. Second scenario, I won the lottery. That F stands for forget you. Then I didn't buy you guys a car. So did I tell the truth?
No.
We're going to give that a false designation, a false truth value. These two, mathematicians decided would both be true outcomes. Because if you look at the third sequence, we have I didn't win the lottery, and then I bought you guys cars. Does that really tell you whether or not I was telling the truth? Because it doesn't tell me anything about what's going to happen when I win the lottery. All that happened was that somehow I bought you guys all new cars. So mathematicians have decided that that is a vague outcome, and we don't really know, so we're just going to put a true in there. Same with this. I didn't win the lottery. I didn't buy you a new car. Did I tell the truth? Yeah, I'm still telling the truth because in that scenario, I didn't even win the lottery, so we don't know what's going to happen. That's why that's also a true. Only one false. Did you hear that? In all of these cases that we're going to look at today, there is one exception, and that's what we're going to write down each time. The one exception is right here. When you have a true hypothesis and a false conclusion, that results in a false truth value for the entire conditional. All the others turn out to be true. If you can remember the exception, you can remember what the rest of the column is supposed to look like. Does everybody understand why these two were true? Because we really weren't saying anything about what happens when I win the lottery. We were just talking about what happens when I don't win. We really don't have any information about that. I didn't make a statement about that. What did this mean? What's it look like? What letter? It's an and situation. What's our technical term for and in the logic units? It is conjunction. And is the only one that's called a conjunction. In English class, what else might be a conjunction? Here, it's strictly and. Let's see. Let's make P the student is a freshman. Q is the student is a girl. And then we'll write the student is a freshman and a girl. Do all of your sheets have lines like this? It's just me? We're going to start off with the same four scenarios. We want a true-true scenario. We want a true-false scenario. We want a false-true, and then we want a false-false scenario. This time we're not dealing with a hypothesis or a conclusion. We're just dealing with two ideas that are going to be linked together with the and symbol. Anybody in programming courses use and?
Yes.
If you want to continue throughout the rest of the if-then statement in a program, what has to happen in an and situation?
Else.
Say that again? Both what? Both statements have to be true. So what we say is and is picky. If I say the only people who are going to pass this course are freshmen and they have to be a girl. So, is that how you spell your name, Valerie? Are you a freshman? All right. She passes the course. All right. Chuck. Is that how you spell? All right. Freshman, not a girl, will he pass? No, not in an and situation. Both parts have to be true. Do we have any sophomore girls in here? So if we had a sophomore girl in here, wouldn't be a freshman, would be a girl. Out of luck. Let's see. Farron. Is it 2 hours?
Yeah.
2 hours. You don't. You're not even close. And is picky. In order to move forward, if I were to place this in a big if-then situation in a program, you wouldn't be able. The computer wouldn't be able to continue the program unless both parts are true. This is another exception situation. Only this time, most of the outcomes are false. And the exception is when we have true, true, resulting in a true. They're not hypothesis and conclusions because we're not dealing with a conditional. It's just two ideas. Are we good so far? Next page. What does the V stand for? This is an or situation. Or, technically called disjunction. That's our mathematical new term. Let's use the same two phrases. The student is a freshman. The student is a girl. This time we're using or. We want the same sequence of scenarios. True, true. True, false, false, true, and then false, false. Or is not picky. As long as one statement is true, you're okay. So if we go back to our choices, will Valerie pass the class? Yes. And let's see, Chuck was second. Will Chuck pass this time?
Yes.
Yes. If we had a sophomore girl in here,
No. She would.
yeah, or a girl, so, and Farron will never get out of here. Ever. Once again, we have a situation where we should look at the exception. No. No. 2112?
You allow.
Not using it.
He did.
So what's our exception this time?
False, false, false.
Write down. False. And false results in false. All others are true. Those are the big three. And if you can't remember what's going on, try to remember the specifics that we talked about. For the conditional, we talked about the lottery. And the only case when a conditional ended up being false was when I promised something and didn't deliver. True led to false. That's considered a false outcome. True, true. True, false. False, true. False, false. What do you think is going to happen when you throw in a negation symbol?
Everything's going to be reversed.
Reverse it. So, to start off with, I always put arrows just to keep track. There's not a whole lot of columns right now, but you might end up doing something that has 7, 8, 9 columns. You want to keep track of what you're relating. This would be false, false, true, true. We're just reversing the first column. Then we're reversing the Q column. False, true, false, true. Whenever you come to a new column, take a look at what you haven't examined yet. We have not examined the arrow. What's the arrow represent?
Conjunction.
Conditional. What's the rule for conditional? What are most of these hopefully going to be?
True.
Most of them are going to be true. And the only one that's going to be false is a negation P that's true leading to a negation Q that's false. The order makes a difference in an if-then statement. So I have to make sure that I'm looking at these two columns in that order. Do any of those result in a false?
Yes.
Which one?
Yeah.
A little box or circle here. This is the only one that has a true leading to a false. That's going to be false. Every other will be true. This year we're learning the real basics of this. This is as difficult as this is going to get. The columns might stretch out a little bit longer, the statements might be a little more complex, but the three main ideas, conditional, conjunction, disjunction, are the only three that you're going to use this year. This gets useful when you take big, complex situations. Instead of having simple statements like that, maybe we're talking about whole paragraphs full of information. And P represents a whole scenario or a plot line to something. And Q represents a whole nother situation. The longer the situations get, the more situations you have, it's easier to take those ideas and reduce them down to letters and symbols, and then manipulate them this way, and then take your outcomes and translate back into whatever the P's and the Q's were standing for. Number 2. right now, I'm handing you all this information. Not only am I handing you what you're looking for, but the entire truth table is laid out for you. As we get better at this, you'll be creating the entire table yourself. So if you see that you have to get to that, negation P and Q, well, you better have a Q column, you better have a negation P column, and then you better know what you're doing with that type of symbol. What type of symbol is that? Or. Is or picky? No. So after I figure out the opposite of that column, does order make a difference, like it did with the conditional? No. So I can just look at these two columns here and here. Do any of those result in false? Just this one. That's the exception for an OR. Only a false will give you a false. Anything that's got a T or a true truth value in it will end up to be true. I'm getting the hang of this. What is this symbol? Is and picky?
Yes.
True, true, false, false, true, false, false. I'm negating this one this time. False, true, false, true. And now I'm supposed to group together or look at this column and this column. Does order make a difference? No, not for and. So right now I'm really ignoring all of that now. What's going to result in a true?
The true and the other true.
Right here. I've got a true, two true components. That'll be true.
Everything else.
Everything else is false because and is picky. Let me get rid of the extra stuff here. That was too much. What happened?
It's that the one that goes to
There we go. So true, false, false, false. Is that right? Question 4. Just because we have more information next to the negation symbol doesn't mean that it's any different. What did we do over here to get this column? All we did was reverse it, right? So as long as I can find a column or make a column that looks exactly like what's inside the parentheses, all I do is reverse it. So we'll do true, 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 false, false, true, false, false. This is just your typical conditional column. What is the only one that's going to result in a false? This one right here. I won the lottery, didn't buy you a car. That's false. Everything else is true. This is just saying negate
So
that.
everything is like it's
F, T, F. I'm just reversing this column. What phrase went along with that type of situation? It is not true that. Here you don't have to worry about that phrase. You're just reversing whatever you determine that to be. You have to think about that when you're making a complete truth table on your own. If you have negation of something, then that something must be somewhere in your truth table. We have to create a column for it. Go ahead, you do 5 and 6. Put in the correct ordering true, 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 false, false, true, false, false for your first P and Q. If we have time at the end of the year, we might show this with some real life scenarios. It depends on how many snow days we get. Right now, we're really just playing with this. You're learning some rules so that when you go to an upper level geometry class or logic course, you actually know what you're looking at when you see a V and an A symbol, and understand that and is picky and or is not. I'll start filling in. Negations are pretty easy. Looks like we have two or scenarios. And then we have a negation here. What does this mean? Another conditional. Does order make a difference with a conditional?
Yes.
Yes, make sure that you're looking at it in the right order. Hypothesis to conclusion. Let's see. Let's put it up here. Did you look at, we had to look at these two columns. This is the negation of that, so that's just. You just have to make sure that this is the same as this. If it's not, then you can't just ignore it. An or situation for P and negation Q. So I'm ignoring the Q column in between. Or is not picky. So true, true, this one would be false, this one would be true. For the conditional, now I'm focused on that and this column, and ignoring everything in between. So just this and this. What's the only way I'm going to get a false conditional? A true leading to a false. A lottery winner leading to me not giving you any cards. So true, true is true, true, true is true. False, false is true. Are they all true?
Yes.
They're all true in that scenario. There's work on both sides. After you do one, check with a partner or somebody around you to see that you're keeping track of all your trues and falses. Have fun. And you always start with true, 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 false, false, true, false, false.